Okay, so the last set of identities we're going to look at is in section 3.3, okay, and they're called Pythagorean identities. And the reason they're called Pythagorean identities is because when you look at them, they kind of look like something squared plus something squared equals something squared. Okay, and that's our first Pythagorean identity. Sine squared plus cosine squared equals 1. Okay, so what's really nice about this is anytime you get a problem and you end up with a sine squared plus a cosine squared, it all just disappears and turns into a 1. Okay, so what that's basically saying is if you take the sine of any angle, okay, somebody give me an angle. It doesn't matter what. 91. So if I take the sine of 91 and square it, okay, plus the cosine of 91 and square it, based on that formula, if I hit enter, what am I going to get? Yeah, and I will. I get 1. Okay, so this is an identity. It works for absolutely any angle you want to plug in. Positive, negative, decimal. Doesn't matter. All right, let's take a look at our second identity, which is 1 plus cotangent squared equals cosecant squared. Okay, and I can plug in numbers and show you that that one works, but I'm not going to. Let's look at the third one. For the third one, I'm going to show you where it comes from based off of the first one. Okay, let's take the first one and divide everything by cosine squared. Okay, so I'm going to take that original identity. Let's divide that by cosine squared. Divide that by cosine squared. And divide that by cosine squared. Let's start with the easy one. What's cosine squared divided by cosine squared? 1. Now, I want to know what sine squared divided by cosine squared is. And if you get stuck, just start with what's sine divided by cosine? It's tangent. And I told you yesterday you can use that identity with a higher power. Right? So sine squared over cosine squared is tangent squared. Okay? And how about 1 over cosine squared? If you get stuck, just think what's 1 over cosine? 1 over cosine is secant. So what's 1 over cosine squared? Secant squared. And that is the third Pythagorean identity. So honestly, I don't really remember the second and the third one. I just remember the first one. And if I need the second or third one, I can figure it out pretty quickly, like I just did. Right? And I could have shown you how to get the second one, just like I showed you how to get the third one, but I didn't bother. Okay? But it's the same idea. Okay? So those are the 3 Pythagorean identities. So at this point now, you know, or I've shown you all the identities you need for this week. Okay, so a lot of the problems you're going to see today are going to kind of be like the homework ones. They're going to say verify. Okay, what I like about the verify ones is they tell you what to start with, they tell you what to end with, and you just have to figure out what goes in the middle. Okay, they're exactly like the homework. Okay, so they'll give you the left-hand side, they'll give you the right-hand side. And somehow you have to show that the left-hand side and the right-hand side are the same. My advice is always start with the side that looks more complicated. Okay, it's a lot easier to take something that looks complicated and cross things out and simplify it than it is to take something that's already simplified and just add stuff that you don't even know what to add. Okay? So start with the side that's more complicated and try to simplify it to the other side. If both sides look like about the same, like you're not sure, like the left side and the right side look like they're the same level of difficulty, then in that case it doesn't matter which side you start with. Okay, what I'm going to do quickly is just look at all the examples we're going to do quickly and see if you can tell me what side looks more complicated. Okay, left side or right side. Let me clear that. Okay, looking at example 1, which side looks more complex, the left or the right? Yeah, left side. Clearly it's got more stuff going on. Example 2, left side, more complicated. Example 3, left side, more complicated. I usually put the left side more complicated, if you haven't figured that out. Example 5, I'd say it's about the same. They both have fractions. They both have a denominator where you're adding something or subtracting something. It doesn't really matter in this case. Okay. And that's it. Okay, so any questions on how to figure out which side is more complicated? Just kind of look at it. All right, and the other thing I want to show you is something like this. Okay, just taking a formula probably most people have seen before. Distance equals rate times time. What's the difference between this and this? Are those different formulas? No. All I did was rearrange the first one to get the second, but it's not like the second one is a brand new formula. Okay? They're the same basic formula. So I want you to take a look at this versus this. Sine squared equals 1 minus cosine squared. Are these different formulas? What did I do to the top one to change it into the bottom one? I did what? Yeah, all I did was I took this and I put it on the other side. Okay, so I want you to realize that when you have an identity in a problem, it might not always be written exactly like this. These are the same thing, okay? Just with cosine moved to the other side. Right? Or I could write the same thing with sine moved to the other side. Okay? There's different ways I can rearrange the same formula. Just like there's different ways I can arrange that formula. Okay? So I'm not going to write every single version of every single way you can arrange all these formulas. Okay? But just make sure you know these 3 basic formulas. All right. So we've already gone through. We know the left side's more complicated, so we'll start with that, and we'll try to turn it into the right. So keep in mind the 3 tricks you have. Okay, what's one trick we can do? And we did practice it in the homework problems. Well, John, do you remember one of the tricks we can do? Forgetting about not this specific problem, but just anything we learned yesterday, like that we used to try to solve the problems. In fact, Dan asked me about something, and I said I'll do it in example 5.
Just changing the cosecant to something else, you mean?
Yep. So that is one. So what could we change things to?
You could change cosecant to 1 over sine.
Yeah, changing everything to sines and cosines. Okay, that's one trick. What's another trick that Dan had asked me about? Yeah. Yep. That's another trick. Okay, very quickly looking at this, I'm thinking there's no conjugates here. I don't even have fractions. No fractions? Oh, that's a fraction. There's no fractions there, and that's a fraction. So if I don't have fractions, I don't have to worry about conjugates. Okay? Most of the problems today doesn't look like we're starting with fractions. Okay? So we've got change to sines and cosines, conjugate, and what's the other trick? We use this one with fractions. Yeah? Finding a common denominator. Okay, just by looking quickly, at first it doesn't look like I have fractions here, here. I do have a fraction there, but I already have a common denominator. No fractions there. And I do have fractions there. Okay, so we'll have to see whether or not we need to use common denominators, okay, as we go through the problem. Sometimes as you go through it, you create fractions. Okay, we'll see what happens. So I like the trick here of what John said. Why don't we change to sines and cosines? Okay. So Shakira, what's cosecant? 1 over sine. Okay, and keep the second thing the same. Okay, just keep it as minus cosine squared. Okay, the right-hand side, I'm not going to keep copying it down. It's supposed to equal sine squared. Well, if you want to copy it, you can. Okay, how about Jared? What you see anything I can do on the? Just focus on the left-hand side. Yep, we can multiply these out, and what's going to happen when I do that? Yeah. Whenever you multiply and you have the same thing in the top and the bottom, it cancels. And now I have 1 minus cosine squared. Okay. Does anybody recognize that? 1 minus cosine squared. Yeah, it's a Pythagorean identity. Okay. I just showed you, you can rearrange Pythagorean identity number 1 and get 1 minus cosine squared equals sine squared. Okay, so what I have right here is Pythagorean identity number 1, if you wrote them in the same order I had them on the board. So at this point, we can say 1 minus cosine squared. That is sine squared. Okay, and the reason how I got from here to here, it's Pythagorean ID number 1. Okay, that's the explanation. Okay, and once I changed that using Pythagorean identity number 1, I ended up with the same thing on the left and on the right. And I'm good. I'm done. Okay, so that's the goal. So always try to turn the left-hand side into the right-hand side. Any questions on that? Now, is that one that, if you didn't know anything else about Pythagorean identities, could you have done that one in the homework last night? Would you have known that 1 minus cosine squared is sine squared? No, we didn't learn that identity yesterday. Okay, we didn't know the Pythagorean ones. Not every problem is going to have a Pythagorean identity in it. Okay, so some on the test might, some might not. Right? Some might just be like the homework problems last night. But generally, when you start to see things that are squared in a problem, especially a couple things, that's when you might start to think, okay, a lot of things squared, it could be a Pythagorean identity. All right, so now they want us to try to turn all of that stuff on the left into secant. So somehow, if we do everything right, everything on the left is going to cancel out and just turn into secant. Okay, how about Karen? Any thoughts what I could try to do first on the left side? Sure, we can distribute. Okay, so let's multiply sine out to what's inside, and for now, just multiply it out and don't do anything with it. So you've got sine times cotangent. You know what? Just write it like this. So sine times cotangent plus sine times tangent. Okay, and it equals, I'm not going to keep copying the right set. Okay, so now I distributed. I like that idea. What could I do next? Okay, what could you change cotangent to? Yep, cosine over sine. That's good. Okay, anything else I should change?
Tangent,
Yeah, what could you change tangent to?
sine over cosine.
Sine over cosine. Okay, so now we've got everything as sines and cosines. All right, what's going to happen now? Okay, whenever I have multiplication, I can cancel if I have the same thing in the top and the bottom. Now, could I cancel the cosines? I got one in the top, one in the bottom?
No.
No, that's addition. Okay, you can't cancel across an addition sign. And there is nothing else that's going to cancel on the right-hand part.
Can you simplify it though?
Yep, what would that simplify to?
Sine squared over cosine?
Mhm. Okay, so sine times sine does simplify to sine squared over cosine. Okay, any questions up to that step? All right, so we've done the trick of distributive. Okay, we did that. We changed things to sines and cosines. What's another trick that I had? Mhm.
Did you change it to common denominator?
Yes, I need a common denominator. And once I find a common denominator, that's going to cause something to happen. Okay. Sam, what's my common denominator here?
Cosine.
Yeah, to find the common denominator, take the two that you have and just multiply them together. Now, the denominator on the right is all set. Okay, there's nothing I need to do to turn that into the common denominator. It already is. Okay, so just leave that one alone. But what about the denominator on the left? What would you have to multiply by to turn it into the common denominator? Cosine. And if you do it on the bottom, where else do you have to do it? You do it on the top. So now cosine times 1, there's my common denominator. And what's cosine times cosine? Cosine squared. Okay, now there's something there you have to recognize. It's something we learned today. Does anybody recognize something there? I'll give you a hint. It's the difference between recognizing 3 plus 4 and 4 plus 3. It's not exactly the same, but it basically is if you do that. Yep, Sam?
Top of the equation is the Pythagorean identity 1.
Yeah, it's cosine squared plus sine squared. Go back and look at our identity. Cosine squared plus sine squared. The order you add them doesn't matter. So what happens to the top? This whole thing just turns into a 1. And now at this point, I'm basically almost left with my answer. That's an identity we learned yesterday. What's 1 divided by cosine? Secant. So we got secant theta, and that's what they said we should get. Okay, so that one had a lot of stuff in it. It had distributive, change to sines and cosines, common denominator, Pythagorean identity, and then our last one was a reciprocal identity. So that's got pretty much everything you could possibly have in one problem, except conjugates. It didn't have a conjugate. Okay, any questions on that? So that might be a good one. If you make a reference sheet, put something similar to that on it, so then you have a lot of different stuff happening there, and you could look back at it as you're trying to do the ones on the test. All right, so this one. tangent plus cotangent divided by secant times cosecant. Okay, any thoughts what we could try first? Okay, what would you want to change it to? One over cosine? Okay, you could. And what about cosecant? You could change it to 1 over sine. Off the top of my head, I don't know if that's going to help. It might, I'm not sure. I haven't figured out how to do this problem in my head yet. So it's an option. You could change tangent.
The 1 over cotangent, and then that just simplifies the whole.
So you're canceling across a plus sign? Yeah, we can't cancel across a plus sign. Anyone else have any thoughts before I pick one of those options that Connor just said? Again, I don't know which option is going to work the best. Yeah, I think those are pretty much the options. Were you going to say something,
Oh,
Connor?
yeah, I was just gonna say, we get all like sine or 1 over sine.
Make everything sines and cosines? Yeah, we could try that too. Why don't we, I don't know. Let's try working with the top. I'm thinking let's try changing the tangent and the cotangent to sines and cosines. Dan, what were you going to say?
I was thinking you kind of split it out, like you have tangent theta over secant theta times cosecant theta, and do the other side.
Oh, like splitting it into 2 fractions?
Yeah.
So what he's saying is if you had something like this, 3 plus 2 over 5, you're allowed to do this. You can take the first piece and put that over the denominator, and take the second piece and put that over the denominator separate. Any reason why you just think that might work?
I think it would be easier canceling out.
Okay. All right. I wasn't gonna. Let's do that then. I wasn't. I didn't even think of that, but let's try it. So we'll take the first piece and put that over the denominator. Plus, and now the second piece, and put that over the denominator. Now, I'm not sure, in fact, if I've ever tried it this way. So let's see what happens. Yeah, but so far, everything we did is fine. We just used algebra or basic arithmetic to take a fraction and split it into 2 parts. Now I would definitely change everything to sines and cosines, and we're going to hope that this leads us in the right direction and something cancels out. So what can you change tangent to?
Sine over cosine.
So you can make that sine over cosine. And now, what I'm going to do, so I can do it in the same step. Can somebody tell me, and I'm going to write it right below it, what is secant the same as?
1 over cosine.
That's the same as 1 over cosine. And how about cosecant? 1 over sine. So I'm dividing by a fraction in both cases. So if I want to change that to multiplication, what do I have to do with that fraction?
Reset the whole.
So flip it and
Multiply top and bottom.
multiply. So I'm going to go, instead of dividing sine over cosine by 1 over cosine, I'm going to flip 1 over cosine. And instead of dividing by 1 over sine, I'm going to flip it and make it sine over 1.
Wait, we don't need to change the sign. You don't need to change sign. You can leave it 1 over sine and cancel out the signs.
I can cancel out something, but not the signs.
If you don't, those aren't connected. They're 2 different things. You can leave 1 over sine like that and cancel out the signs.
I'm not sure what you mean. You're thinking like I could cancel this sign with this sign?
Yes, because it's top. No, never mind.
No. Okay, you have, yeah, if we're doing it the way Dan suggested, that's how you do it. That's, yeah. All right, and I'll come back to what I can cancel in a second. Plus, what is cotangent? That's cosine over sine. And I can multiply by the same thing. So instead of dividing cotangent by 1 over cosine, I'm going to flip it and multiply. And again, instead of dividing cotangent by cosecant, I'm going to flip it and multiply. Okay, so what's going to cancel out on the left? How about on the right? What's sine times sine? Sine squared. What's cosine times cosine? Cosine squared. And now, does anybody recognize what's sine squared plus cosine squared? That's Pythagorean identity number 1. And what does that come out to? 1. Which is what they wanted. I'd say that was a pretty good way to do that problem. I mean, it wasn't that long. It was really just changing everything to sines and cosines and then canceling. I'm not sure you could find a much faster way to do it. So that was a good suggestion. Okay. Any questions on that one? Okay, and if that doesn't make sense to you, you might have a different way in your head that makes more sense because of the way you think and do things. And if you come to the same answer, that's fine. Okay, as you said, there's many, many ways to do these kinds of problems. All right, so this one says cosecant theta minus 1 times cosecant theta plus 1. Now, as I said, there are lots of ways to do these kinds of problems, but when I see something like that, I'm thinking something right away in my head I should do. Okay. What property could you use right away here? Distributive or FOIL, yep. Okay. Because what are these two things? Cosecant minus 1, cosecant plus 1. They're conjugates. Anytime you have conjugates and you can multiply them, which is what this is asking you to do, always do it. Because if you do it, nice things happen. Okay? Don't change to sines and cosines. If you do that, it's just going to get into a mess. Okay? So this is a problem where changing to sines and cosines wouldn't work. Multiplying the conjugates, watch what happens. Okay. What's cosecant times cosecant? And then cosecant times 1? Cosecant times negative 1. So positive cosecant, negative cosecant. That's going to cancel out. Okay. And the last thing is negative 1 times positive 1 is negative 1. Okay. So now I'm left with cosecant squared minus 1. Let's go back. Does anybody kind of see cosecant squared minus 1 up there hidden? It's the second one. You just go like this. What is cosecant squared minus 1 the same as? It's the same as cotangent squared, which hopefully is what they wanted me to get. Done. Okay. So just by multiplying out the conjugates, you're done in one step. Any questions on that one? That's not the only way to do that problem, but it is the fastest. Anything else you do would be longer than what I just did. Okay. All right. So the last one. All right. So this one says to verify that what's on the right and what's on the left are the same. But we talked about it earlier. Which one looks more complicated? They both kind of, I would consider these both the same level of complexity. So it really doesn't matter. We can start what's on the left and change it into the right, or we can start with what's on the right and try to change it into the left. Which way you want to do it? Change what's on the left into what's on the right? Okay. Okay, so let's run through the different tricks we could use here. Any thoughts about changing everything here to sine and cosine? It already is. So changing to sines and cosines isn't going to help. How about a common denominator? Would finding a common denominator help? No, how come? I'm not adding two fractions. To have a common denominator, I need to have something like this. I need to have two denominators that are different. I only have one denominator, cosine. Okay, so common denominator we can't do. Is there a distributive property? No, for distributive property, you've got to get something on the outside of parentheses and something on the inside. Okay, we don't have that. So what's the only trick left that I have?
Reciprocal identities.
The conjugate. Okay, that's the only thing left I could possibly try. Now, usually we multiply top and bottom by the conjugate of what's in the bottom. Does the bottom have a conjugate? No. Okay, it's just a single thing. Single things you don't use conjugates, but the top does. So let's try that. It's not something we normally do, but we can give it a shot. What's the conjugate of what's in the top? 1 plus sine. And another hint that it might be a good idea to introduce the conjugate here. Look at the final answer. It has 1 plus sine in it. So by multiplying by the conjugate, we're probably doing something right. Okay, because hopefully stuff cancels out. All right, let's multiply the top, because I told you, anytime you have conjugates, always do it out because nice things will happen. So what's 1 times 1? And then 1 times sine? What about 1 times negative sine? So that cancels. Okay. And Jesse, what do I get when I do negative sine times positive sine? Yep, negative sine squared. Okay. And now here is where just kind of practice and experience helps you. I'm going to leave the bottom the way it is because I already know what's going to happen with the top. I'm looking at that, I'm already seeing something in my head happen, and I'm seeing something in the bottom that's going to cancel out. So don't distribute out what's in the bottom. Just leave it as cosine times 1 plus sine. Okay, now look at the top. 1 minus sine squared. Let me go back. Does anybody recognize 1 minus sine squared as something? Sam? It's the first one. Okay, if you do this, and move the sine squared to the other side, what is 1 minus sine squared? It's cosine squared. Okay, so let's change 1 minus sine squared to cosine squared. So I have cosine squared in the top, and I have cosine times 1 plus sine in the bottom. What do the top and bottom have in common now? How many cosines are in the top? 2. How many in the bottom? 1. So I can cancel 1 from here and 1 from there. Right, so I canceled 1 from the top and the bottom. So I'm left with cosine in the top and 1 plus sine in the bottom, which is exactly what they wanted me to get. So this step right here, of not distributing it out the cosine, if you've ever, like, is anybody that plays chess in here? No? No chess players? Okay, well, chess is usually a game where it helps if you kind of can think ahead 2, 3, 4 moves. So like if you already think you're going to do something because you know what can happen like 3 or 4 moves later. That's kind of what I did here. And that's hard to teach someone how to know. I didn't multiply this out because I already knew it was going to cancel in the next step. So why bother distributing something that's just going to disappear? At first, you probably don't recognize that. So you waste time distributing it out only to undo it and cancel it later on. All right? But it just takes practice to get good at those kinds of things. Okay, so any questions on those problems? All right, so the homework for tonight will be in the book. Okay, some of the problems, I think in 9 through 14, they're not actually asking you to solve it. They just say to do something like this. They'll give you a problem like this, and they'll say, multiply the top and the bottom by 1 minus sign. They tell you what to do. You just have to do it. Okay? And then 19 through 27, those are like the ones I did in class. They don't tell you what to do. You have to figure it out. Okay? So in 9 through 14, they tell you how to do the problem. Okay? And then you can skip 21. You need to skip. Okay, so 19 through 27, just the odds. 21 is a problem that we don't know how to do. So skip. Yep.